friends, this video is just a sort of reminder that you guys already know three ways to solve a quadratic equation. And I just want to take a look at them so that you can take a minute and process what is the same about them, but also what's different. Like how would I choose which method I was going to use if I just happened to encounter a quadratic, like at the bus. Oh, I guess there aren't buses anymore. Or at the, something that's still happening. So on your walk in the woods, for example, if you were to happen upon one of these quadratics hanging out underneath a tree and they, in a social distancing way, asked you for a solution, you would have an idea of how to encounter that. Okay, so let's take a look at this first problem here. So we got b squared equals to 4. So hopefully the first thing that you're noticing here is that it seems pretty straightforward, right? We've got the variable isolated on one side. There's no variable over here on the other side. And there's only one term here, which is our square on the left-hand side. So this is an example of a problem that we're going to solve by taking the square root. Okay. Some things that will trigger you to know that you're going to take the square root are you have a perfect square variable that is alone on one side, right? Or maybe it's not alone, but you can get it alone, right? And then the other side is just a number. Okay, so there's no linear, another way to write that is there's no linear term. And a linear term would be just like a b, plus b or minus b or plus 8b. But there's no other b's. There's just this square and just a number here by itself. Now this number doesn't have to be a perfect square, right? This could be 8, and I could take the square root of 8 and just be 2 root 2. It would be irrational. But, it's sort of an added bonus if they're both actually squares. So I'm just going to take the square root of both sides. And then the important thing to remember when you're doing that is that you end up with two solutions. You end up with the positive case and the negative case. So b could equal to positive or negative 2. So if we were solving for roots, the 2 points that we would have would be 2, 0 and negative 2, 0. I guess I would probably normally write those the other way around. Let's take a minute and do that correctly. And there's our solution set for those roots. All right, so if I were to look at this one, so notice here, if I were to try to get this r squared by itself, maybe moving the positive 7r to the other side by subtracting 7r and adding the 8 to both sides, I'd have variables then on both sides of the equation, right? So I can't, in order to get this square alone, in order to get the quadratic term alone, I'm going to have variables split on both sides of the problem. So I'm not going to be able to use the square root method for this problem because it's got a linear term, right? So if I have this linear term, I'm going to have to check to see if it's possible to factor. So remember that if I'm trying to factor something, I would multiply a times c and see if I can figure out two values that sum to b. And you can do that just with the numbers as like a quick mental check. So is there something that could multiply to negative 8 and add to positive 7? And, oh, sure, positive 8 and negative 1 would add to positive 7. So if you can find those two values relatively quickly, right, then you're going to factor. Okay? Um, so remember that factoring, you could either use product and sum, or there could be a greatest common factor. Sometimes that greatest common factor is even a variable that you can factor out. And you can also use some of those special cases, right? Like the difference of two squares. And sometimes you might also have a perfect square trinomial. Okay. So here I can factor them into 8 and 1 because a is equal to 1. It's just going to be r times r, and I've got positive 8 for one of the factors and negative 1 for the other one. And so I can split that. So r plus 8 is equal to 0, r minus 1 is equal to 0. And so my solutions here are r is equal to negative 8 and r is equal to positive 1. And so my solution set is negative 8 comma 0 and 1 comma 0. Those are my roots for this equation. Okay. So factoring. So factoring is generally going to be not as fast as if you can just take the square root of something, but it's going to be faster than if you have to do the, well, I don't know. These last ones are a little tricky because I'm not always sure that you have to use factoring, right? There are places where you could use factoring, but maybe completing the square would be more efficient. So just to be clear, there is a little bit of wiggle room here. But when do you have to use completing the square? So this last method that we know is completing the square. So and actually I'm going to erase some of the rest of this stuff here so that I don't get confused visually. Okay. So in this last case, we're going to, and I'll just move that up, we're going to complete the square. And so I'm going to use completing the square when? Like when do I have to use completing the square? When will the other options not work, right? So let's take a look at this problem right here. So here, if I were to, let's say I were to set this one equal to 0. So I'm going to do plus 8 plus 8. So I've got x squared minus 15x plus 3 is equal to 0. So now can I find two factors, right? Can I find a product that gives me positive 3 and a sum that's negative 15? In other words, my a times c is equal to 3, and I want two factors of that when added give me negative 15. And I think pretty clearly you're going to see, well, that's not possible. So it's not factorable. Okay. I can't take the square root because I can't get the x squared alone because there is a linear term, right? So there's a linear term. It's not factorable. So now my only option is to complete the square because I can always use completing the square. Okay. So then if I move 3 to the other side, I'll get x squared minus 15x is equal to negative 3. And then this is going to be one of those ones where I would probably want to multiply through by 4 and solve it. And actually, I'm not even going to solve it here because what I'm really interested in focusing on here is that we can use the completing the square when we can't use the other options. Okay? So I would like you to take a minute and reflect on these 3 different ways to solve them. And please write out a sentence or two for each way. to explain how are you going to remember when am I going to take the square root, when am I going to factor, and when am I going to use completing the square when you encounter them. And then you can do a little practice. Okay, thanks.